So here's another dimensional analysis problem. We're trying to figure out how many kilometers in 898 meters. So the unknown, x kilometers, we set that equal to the known, 898 meters. Put a time sign on the line. Meters has to go in the denominator of the first conversion. So here's an example where what we're looking for is basically the same unit as what we're starting with. We're starting with the distance in meters. We just want to put the prefix k onto the meters. So whenever you are adding a prefix or removing a prefix, we're using the values from table 2.2 that you have to memorize. So we're going to turn meters into kilometers, and notice, write down your units before you put in any numbers. Now, the definition from table 2.2, kilo is 1 times 10 to the third power. Notice those two things are on opposite sides when you write it out like this with an equal sign. When you put that into the conversion factor, this is very important. The value from the table, 1 times 10 to the third, never goes with the prefix. So the k, kilo, is on the top. The value of that, 1 times 10 to the third, must go on the opposite side. You don't want to try to memorize it always goes on the bottom, because in other problems it's going to go on the top. What's always the same is the value k, kilo, its numerical value goes on the opposite side. And the value that you put with the k, in this case, is just a 1. This is always going to work whenever you're adding a prefix or removing a prefix. The fraction side that has the abbreviation, in this case k, always gets a 1. The opposite side of the fraction always gets the value from table 2.2. And if we count sig figs, 898 meters has 3 sig figs. Table 2.2, remember, is exact, so this is an infinite number of sig figs in both the top and the bottom. So our answer should have the smallest number, which is 3 sig figs. And you should get, in scientific notation, 8.98 times 10 to the negative first kilometers. So double check that the units, the question was asking for kilometers, and we did calculate kilometers. The magnitude, a kilometer is much bigger than a meter. There are 1,000 of these little meters in 1 kilometer. So if we have almost 1,000 of these meters, we have almost 1 kilometer. 8.98 times 10 to the negative first, or normal notation 0.898, is a little bit less than 1 kilometer. So the magnitude of the number, we expected something small, and we got something small. The calculations could involve a question like here, where we have milliliters and picoliters. So we have 2 different prefixes. This is another very common type of conversion you're going to do. We're using the same technique. Unknown, how many milliliters? The known, 8.00 times 10 to the negative fourth picoliters. So instead of just one step, this is going to take us 2 steps. We have the prefix, the known prefix is picoliter. So we're going to put a time sign on the line. What you never want to do is try to change one prefix into another in one step. Instead, go back to the base unit. The base unit is the unit without the prefix. If you get rid of the prefix p, you have the base unit, which is liters. So just like in the previous problem, pico, we know the value from memorizing table 2.2 is 1 times 10 to the negative 12th. That is not going to go in the bottom of this conversion because that's where the pico is. 1 times 10 to the negative 12th must go in the top, and we put a 1 with the pico. So we are removing the pico and going to the base unit of liters. We're not done until we get to the same unit as we want, which is milliliters. So I need to put the liters in the bottom, and now I can add the prefix that I want, which is milli. Milli is 10 to the negative third, so 1 times 10 to the negative third goes on the opposite side of milli, and milli gets a 1. If I check to make sure the units are canceling, picoliters cancel, liters cancel, and I'm left with milliliters. When these two units are the same, then we're done with the conversion steps. Now we have to multiply through, and notice anything that's in the top of the fraction, the numerator, gets multiplied. Anything that's in the bottom of the fraction gets divided. So when you plug this in your calculator, 8 times 10 to the negative fourth times 1 times 10 to the negative 12th. We could divide by 1, but there's really no point because dividing by 1 doesn't change the value. So I recommend not dividing by 1, and in the next conversion you have a multiply by 1. So we're just going to multiply whatever's in the top, divide whatever's in the bottom. If you do it this way, you only hit the equal sign one time. So I would go from left to right the way the problem is written. If you have a number in the top, multiply it. If you have a number in the bottom, divide it. And then your calculator answer should be, in this case, 8 times 10 to the negative 13th milliliters. In terms of sig figs, the original number has 2 trailing zeros, which are significant because of the decimal point. The other 2 conversions are from table 2.2, so they're infinite. So our answer right now looks like it just has 1 sig fig. To write that with the correct number 3 sig figs, we need to add 2 trailing zeros.